Everyone, today I'm presenting my final project, Amazon Book Review Recommendation System. It is a big data pipeline on GCP. So first, let's take a look at the data set. It's from Kaggle and it's a Amazon US customer review data set. The size is 3.24 gigabits and it has more than 3 million reviews. So it is a quite large data set. And the purpose is to build a recommendation system to recommend books for users. This is the pipeline architecture of the project. So first I upload the dataset into the cloud storage and I use Apache Beam to do some EDAs. And then I use the SQL and BigQuery to ingest the data into the BigQuery. And also I use the SQL to process the data and store the processed data back into the BigQuery for the further use. And the next step is model training. I use Spark as well as scikit-learn to train three different models, and I evaluate these models and present the results in a Jupyter notebook. This is the main pipeline of my project. The GCP services I used, including cloud storage, Dataflow, BigQuery, and Dataproc Workbench. And yeah, this is the cloud storage bucket that I use to store my data set. It's 3 gigabits. Next, the pipeline has three parts. The first part is the EDA with Beam. We can just jump into the notebook. So first I load the data into the using Apache Beam and do some basic EDAs. First is the sample, show some sample data and show the size of the data set. Because this data is quite large, so this step takes about a few minutes. The second step is rating distribution analysis. We can see that most of the reviews is 5 stars, and also I analyze the user and the item. So there are only 8% of customers have multiple reviews, and also only 16% of the customers of the products has multiple reviews. So the data is quite sparse. We need to handle this problem later. So in this notebook, I used the direct runner of Beam, but I also tried to submit the job to the data flow. So this is the job I previously submitted. We can see the pipeline of the job, and it takes about 7 minutes and it costs only 1 cent. Yeah. So one interesting thing I found in this process is submitted the pipeline into data flow is actually slower than do them locally. This is because the starting of the pipeline takes a while. So yeah, that also means the dataset is not large enough for the Beam. And the second part is the data pre-processing. We can also go to the notebook. So first I use the BigQuery client to create a BigQuery dataset and define the schema of the tables. And then I load the data into the BigQuery, and we can see that we load all the 3 million rows into the table. And next step is I did the same EDA with BigQuery because BigQuery is fast enough. So I also did some test. And next step is data pre-processing and filtering. So I basically filter the reviews and I filter the item and the user with more than 30 reviews, so the data is not that large, and also it's better for the collaborative filtering models. And next step, I created a filtered data set and store them into the split them into the train and testing data set and store them back into the BigQuery. And also I validate the data before I move to next step. Yeah, this is part 2, the data pre-processing. You can see that after pre-processing, our data is from 3 million to like 114K. The third part is modeling. I use 3 different models. One is ARS, one is SVD, and one is NMF. These 3 models is basically different ways to decompose the user and item metrics into smaller user metric and the item metrics. So we can also go to the notebook. Yeah. So I initialize the Spark session and load the data from BigQuery. And for the first model, ARS, I use the it is originally supported by the Spark Machine Learning Lab. So I just use the model from the Spark Machine Learning Lab. For the second and the third model, they are not originally supported by Spark, so I transfer the data into the pandas data frame and use the scikit-learn to use these models. And we can see that for these 3 models, this is the evaluation and the training time of these 3 models. Yeah, and I also did a compare these models in the end. So we can see that for these 3 models, the best model is SVD. It has 0.07 recall and 0.04 NDCG. So these numbers are not good, but for this kind of sparse data, it is a normal performance. And also for the hyperparameters, I didn't fine tune them. I just choose some random hyperparameters from experience. So if I fine tune the model, the performance will be better. Yeah, that's the third part of the project, is the modeling. And the main challenges of the project is, so first is the scale of the data set. It's over 3 million reviews, so it's quite large. It's slow to handle them locally, so I use the data flow and the BigQuery for EDA and for processing. And the second problem is the sparse user item metrics. So I used a simple way to fix this problem. Just filter the reviews with more than 30. Filter the items and users with more than 30 reviews. So this is not a perfect solution, because we also need to handle those users and products with less than 30 reviews. But this is the point is not the performance, so I just use a simple way to handle this problem. And the third challenge is debugging. So I ran into a lot of bugs during the coding, so it's hard to to debug. So as a result, I use Jupyter Notebook as a main environment to quickly test and debug my code. Yeah. So for the future work, the first is I can submit the Spark to Dataproc for distributed training. It will be much faster, and I can also try to use more data for the model training. And the second is I can process the reviews with NLP and also build some hybrid recommendation models, as well as the hyperparameter fine-tuning, so the model would have a better performance. And the last is to deploy the model as a web service with API access, so we can really use this model to do some prediction. Yeah, that's all for my presentation today, and thank you.